casting processes and furnaces for automobile engineering. We will study in detail about the casting process. In this tutorial, we will say a brief introduction to casting process and what is sand casting process, investment casting, die casting, and other casting methods, plus cupola, furnace operation and construction. Okay, the quality and selection process for castings. Here, let us understand the importance of casting process. It's a near knit shape manufacturing. Casting forms complex shapes directly by solidifying molten metal in a mold. It can produce thick sections and internal cavities that machining struggles with. Okay, here what are the automotive part applications? Common examples include engine blocks, housings, brake drums, and brackets. It enables strong, heavy components where welded fabrication is inefficient. Okay, why we have to choose this casting process? The chosen process controls cost, dimensional accuracy, and surface finish. It also affects casting soundness, strength, and achievable production rate. Let's see the casting process categories. There is expendable mold castings and permanent mold castings. The inexpendable mold casting, the mold is broken after solidification to remove the part. Typical examples are sand casting and investment casting, where we are breaking the mold after taking the part. Okay, permanent mold casting, a metal mold is reused for many cycles and parts. Typical examples are die casting and gravity die casting. How to choose the family? Match the method to alloy, part size, and required quantity. Selection impacts accuracy, surface finish, and production rate. Sand casting process. Let's understand the basics of sand casting. Here, a pattern is used to shape a cavity in compacted molding sand. The mold becomes a one-time form that defines the part shape. How molten metal fills the mold? The metal is poured and guided through a gating path into the cavity. Proper flow helps the cavity fill before metal begins to freeze. Why it is used in automobiles? It suits large components and low to medium production volumes. It can produce complex shapes without expensive permanent tooling. There are two major types: closed and open molds. The open mold concept, the mold is a single cavity exposed at the top surface. Metal is poured directly into the open cavity by gravity. You can see the figure in the right side, the first one. The second one, closed type. The mold is assembled from joined sections, typically cope and drag. A gating system feeds metal into the enclosed cavity. Why closed molds are preferred? They can form more complex shapes used in automobile cast parts. Controlled metal entry improves fill consistency for detailed cavities. Let us understand the sequence with which we have to do the sand casting. First, pattern and setup. You see that? Make the pattern to create the required part shape in sand. Prepare the flask half so they align during molding. And then next step is mold making. Form, cope, and drag. Then create the cavity from the pattern. Add metal flow passages so molten metal reaches the cavity. Pouring to finishing. Pour molten metal, allow cooling, and let the casting solidify. Do shakeout, fettling, and inspection before the part is used. What are all the elements in sand mold? In sand mold, we have metal entry and control. The pouring basin steadies the steam before it enters the sprue. The sprue drops metal downward while limiting splash and air pickup. Distribution to the cavity, second step. Second element. That's a runner carries metal across the mold toward one or more gates. The gate meters the flow into the cavity for a calmer fill. Casting quality impact. The cavity defines the component shape and surface detail directly. Good gating design reduces turbulence, defects, and wasted metal. Let's see the cross-sectional view of the sand casting process. It will show you how the metal entry and sprue looks like. The molten metal is poured into the basin, then drops down the sprue. A steady sprue flow reduces air intake and metal splash. Runner and gate flow path. Metal turns into the runner, then passes through the gate. Gate feeds the cavity below the cope with a controlled flow. The section view teaches what the section view teaches us. You can trace metal movement from top entry to final cavity fill. The clear flow paths help avoid defects from poor filling behavior. Shell molding idea. How the shell is created. A heated metal pattern is covered with resin bonded sand. Heat cures a thin layer, forming a rigid shell on the surface. Curing and mold making. Loose sand falls away. The shell is oven heated to fully cure. The hardened shell is stripped off and assembled for pouring. Why is it used? Shell molds give better surface finish and closer dimensions than grid sand molding. Investment cast Investment casting process principle. First, we have to take it in three stages. Wax pattern stage creates a wax replica of the component as the starting pattern. The pattern assembly attach multiple wax patterns to a common spool to form a tree. Why it's chosen? Best suited for intricate shapes and fine surface and edge detail. Steps in investment casting. Build the ceramic mold, coat the wax pattern tree with a thin refractory layer first, add more refractory unit. The shell becomes rigid and strong. De-wax and prepare for pouring. Heat the mold so wax mills out, leaving hollow passages. Preheating also clears the contaminants and helps metal flow easily. Pour and recover the castings. Pour molten metal into the sprue. cavities fill and solidify, break away the ceramic shell, and cut parts from the sprue. In the right side, you can see the cross-sectional view of the investment mold. After dewaxing, only hollow passages will be there. Heating melts wax, leaving a ceramic shell with the sprue channels. The empty network becomes the flow path to each part cavity. Metal flow in the tree. Molten metal is poured into the main sprue at the top. It branches through runners to fill multiple component cavities. Why it casts many parts? Several small complex parts solidify together on one sprue tree. Parts are separated from the sprue after breaking the mold away.